This is a dry slab avalanche that was triggered by a skier on March 24th, 2024. Partly to estimate the destructive size with two different methods, 2 days later I toured up to the upper and lower deposits, shown in pink. Here's a look at the upper deposit. The larger blocks were described as being as big as a Ferrari, which caught my attention. Having been there and sat on one of the blocks, I agree. This is the first and faster method for estimating avalanche size. It is the help chart from the US Avalanche Encyclopedia and has also been called the more visual method. Let's consider the destructive potential. The upper deposit could easily bury a car. I wasn't sure if the avalanche could have destroyed a large truck, so I'll show the uncertainty by the height of the red box. The run length to the toe of the lower deposit is many football fields long and close to 1 kilometer. So here's the box for run length. I estimated that the upper deposit could fill 2 hockey rinks 3 to 4 meters deep. So the deposit has the volume that is typical of a D3 or 3.5. Including the smaller, lower deposit does not change the volume estimate. Combining these 3 factors, this avalanche is a D3 or 3.5 according to the more visual method. I lean towards a D3.5 because deposit volume is less uncertain than destructive potential. It's hard to be confident about destructive potential because I haven't seen the terrain and deposits for avalanches that destroyed cars, houses, and/or large trucks. Next, let's use the more quantitative method, which is partly an office method. This chart shows the column for D2 to D5 avalanches from the Canadian scale. This is the column for volume from the European scale. More on it in a bit. For this avalanche, the destructive potential is the same as for the field estimate from the more visual method. Using Google Earth, the run length is about 800 meters, which is just below what is typical of a D3 avalanche. Using my field estimates of deposit depth and combining estimates of deposit area from the field and from Google Earth, the volume of the 2 deposits is about 70,000 cubic meters. Again, the height of the box shows the uncertainty. While walking on the deposits, I estimated the density to be about 400 kilograms per cubic meter, which gives a total mass of about 28,000 tons. By itself, this suggests the avalanche is a size 4. However, several colleagues and I have found the mass estimate for an avalanche tends to be of a larger size than indicated by the other factors. So, combining the factors and ignoring deposit mass, I'd rate this avalanche as a D3.5, but D3 is also a reasonable rating. For this avalanche, the more visual and more quantitative methods give the same result, which is not surprising since the more visual method is based on the more quantitative method. However, this is just one avalanche. Note that the European scale and the American help chart use deposit volume to rate avalanche size. Also, Tyler Carson and colleagues have proposed changes to the Canadian scale, including using the column for deposit volume from the US help chart. For sure, there are a couple of controversial ideas here, so let's have a discussion in the comment section below.